Okay, so no new information today. Just trying to review what we've been working on in these two word problems. So on Monday, I'm going to give you three questions to do on your own open note, and I'm going to collect that and grade that right or wrong. Okay. So today, here's your assignment. Write that down. All things we've already covered, so nothing new. We're just going to apply these two word problems, and then you should have some time to ask questions in class today. So let's get into it. Number 13 on page 148. Something about a diver inspired by the Olympics. So I like this because we did a basketball problem and we talked about how flat a basketball travels when a player passes it across the court. But a diver has like a very different parabolic path, but still a parabolic path. It goes up and comes down, and it's like a tall and skinny parabola. So I like how we can talk about a basketball as a wide parabola, and a diver goes up and down as a skinny parabola. You're jumping off a diving board into a pool. The maximum height of 25 feet after traveling 1 foot horizontally. That's always the scary thing about diving is like here's the diving board and you're landing like a foot away, right? You're really close to it. You hit the water 6 feet out. Oh, you hit 6 feet out from the diving board. The path of your dive is a parabola. Y is the height and x is the distance. What is the height of the diving board? It's either a high dive or a low dive, right? Okay. I need to get a visual on this. So here's my diving board. I'm gonna jump. Here's my diver. Alright, we don't know the height of the diving board. When he goes up, lands, these are water. Okay. So we do know this point right here. The information here has told us the vertex. Can anybody pull the values of the vertex out from these words? Mm-hmm. Yeah. Well, you got your X and Y, right? That's so good. We're gonna mix it up. So 1 foot horizontally, and so you guys maybe underline and really emphasize this word maximum. That means it's the highest point. So you'll hear that a lot in quadratic word problems. Maximum typically means they're telling you a vertex, or maybe even minimum. Yeah, so it's a height, and we know height means y. So we're going to go with y equals 25. And then horizontal, that refers to the x-axis. So we'll go with x equals 1. So this height, or this vertex, I should say, is 1 foot away, and it's 25 feet in the air. Everybody buying into that? Now, since it's the vertex, we're not going to just call it a plane xy. It is an xy, but it's the most special point in the parabola, so we need to remember that and give it its special letters. That's the hk in the vertex form of the formula for the parabola. So go ahead and write down the form that uses hk and plug in h and plug in k. Start with that. Has anybody done that yet? Okay, I'll wait a minute. Look at him. Today. So HK is 1 in 25. So maybe I'll do it. So I'm going to go with the model. That includes vertex. X minus h squared plus k. And I'm going to plug in our horizontal distance and our maximum height. Anybody get this far? Just one person, two people. Anthony, you got it?
I put the wrong number.
What numbers did you put?
Like I had it flipped around.
Oh, yeah, get that because they said the 25 first. So I totally understand that. Where do I see you get that? There you go. Okay. All right, good job. Got our vertex in the right spot. The x is the 1, the y is the 25. We're supposed to be given another point. Like we need something to plug in x, y for the whole process to point. So what's the other point? Like, do we have enough information? Is there another point here? We need a regular x, y. Yes. 6, 0. Yeah, 6 is in here, I remember. Okay. Very good. Yeah, it says you hit the water 6 feet from the diving board. Well, that's an x-intercept. Well, I'm gonna confuse you guys. So, that means right here, kind of like that. This entire distance was 6 feet. So this ordered pair would be 6 comma 0. And that'll be the x and the y that we plug in with the h and the k. And then you can do your math and see how it goes. So y is 0, x is 6. Go ahead and find a. Find a. Should be negative, I think, because the arrows are going down. It has a high point. It looks like a hill. Should be negative. Okay. That'd be cool. You can work with a negative one. Oh, zeros are always a little complicated. So, yeah, I'll subtract 25 over. And negative 25 equals a. 5 squared is 25. Divide by 25. And I agree. Negative 1 is our a value. Dang, that's pretty good. It's morning anyway. All right, that's just halfway through. We're in a really good spot. And actually, when I plug in this negative 1 and that HK, I'm 75% of the way through. So we're doing great. All right, so we found A. A equals negative 1. So let's start over. And we're going to use H, K, and A in the model. So we're plugging in the vertex form because that's the information we were provided. So it's negative 1 x minus 1 squared plus 25. And that's a solid 75% right there. A lot of work. A lot of work goes into that bit. And this is a full equation. We could now put this into Desmos and see the entire path of the diver. Because Desmos, this is a quadratic equation. It's just that we want to end in standard form. No, you have to end in standard form. It'll be one vertex form, it'll be one intercept form, and it'll be one graph standard form. So there's a handout with steps with the negative b over 2a. So it's 3 questions. It's very specifically one graphing standard form, one doing this process, and one doing this process, but starting with intercept form. No, you can use all your notes, all of your book, and a calculator. No, it doesn't. No, no. You have access to a scientific calculator does most, but you can't use the graphing tool. The SAT gives you the graphing tool, but maybe like one question of the whole thing. And then ACE Math 1 gives you nothing like that. It just gives you the TI-36. Yeah, the ACE Math exam, you can only use that TI-36.
What is ACE Math? Is that counting?
Yeah, it's statistics and it's pre-calculus calculus. And if you pass it, it's a college credit. And then you go to ACE Math 2, which is AP calculus. You get credit for AP calc, which is another college math credit. You have to take AP test for AP calc. You take ACE Math 2. You take a Cambridge exam. But our public universities recognize it as an AP calc credit. Gosh, let's move on. I feel like we've done X minus 1 in 3 of our problems. But you don't have to take any of those hard classes. This could be the hardest math class you ever take again. Honestly, there's so many options after this. You can just go easier. Pretty much, if you don't take ACE Math 1, your next class will be easier than this one. That's kind of nice, right? Like a relief. Your next class will repeat this content. There'll be less homework. The test will be a little easier. If you don't take ACE Math 1. You don't have to take ACE Math 1. No. No. If you get an A or a B in this class, you will be put into ACE Math 1. But you can like refuse, but you should just take it. If you get an A or B, it means you're pretty good at math. Even if you get a C, you're pretty good at math. What's that? Then you don't take ACE Math 1 unless you like insist upon it. Even if you get a C, we don't put you in ACE Math 1. You know, you already stressed out. Like, just take a little in your class. Right? We almost did. Okay. So I did that whole FOIL bit. I get x squared minus 2x plus 1. Then I distribute negative 1 through. And I get this. I boxed this for a second thinking I was done, but I'm way not done. What did I forget about? It's a really common mistake, so I'm going to highlight it here for a whole minute. What do I still need to do here? The 25. There's still a 25 here. So notice okay, so I pulled this, I wrote them side by side, foiled it, and I got this. I pull the negative 1 from the front end. I also have to remember to drag this 25 down. So there's still a plus 25 at the end of this. So now my final answer is negative x squared plus 2x plus 24. So this person like did not jump very high. Because their highest height was 25 and the diving board is starting at 24. This is not like the Olympics at all. Those people jumped really high. Oh, maybe it's more like a platform. You guys have ever seen platform diving and springboard diving? Like the platform, you can't jump that high off of. Yeah, it's like concrete. You're just jumping off of concrete, not a spring. Okay. So what is the height of the diving board? This y-intercept is the height of the diving board. because that's how high the person was when they jumped. So answer in a complete sentence. The height of the board is 24 feet. Next one, let's do 16 now. We have a long chat about that. Alright, this one's about a scuba diver. The elevation of a scuba diver, X is the number of minutes when they leave the boat, and Y is the diver's elevation. So this time we got a boat. Scuba divers don't always go off the sailboats, but sometimes they do. And then here's the scuba diver going down to see the fish. Okay. And so I'm starting at 0, 0. I'm in scuba dive. And then 4 feet out, I'm all the way 24 feet down. I think it's kind of far. I don't know. Any scuba divers in the room? Oh, you guys do scuba dive? It's 24 feet down. Like, far?
No, you can do that without it.
That's like snorkel level?
That's not the level for me.
Snorkel level for some, not snorkel level for others. I think that seems pretty far. Okay, and then okay, so they hit this, but problems don't go flat. And then finally they come back up 16 feet from the boat. So when you see a table and you're applying it to a word problem, get a whole visual, do a whole sketch. It doesn't have to be a fancy graph, but understand what you're looking at. This is a negative elevation and then coming back up 16 feet out. Okay. What does it say we have to do? The table shows, yeah, no kidding. Is there a question? Oh, there it is, letter A. Write a quadratic function that models the scuba diver's elevation over time. Okay, let me ask a question. What is the vertex HK? Oh, my bad, 12. Thank you so much. You're 12 feet. He said I had 4 here twice, and he was right. So. Much more accurate now. Colin, do you think that we know HK for this table? Is that Colin? No. I'm gonna put that on. Do you think we know the vertex of this table? Kind of a tricky question, isn't it? What's the very middle? The vertex is usually the very middle. It's usually something right in between the repetitions. They didn't tell us the vertex. No vertex given. So we can't do this model. This isn't designed for this model. It's not gonna work. If you don't have a middle point, you can't use that model. Instead, we're gonna use the x-intercepts. I see zeros here and here. These are x-intercepts. So when you're given x-intercepts, you have to use x minus b times x minus q, and then don't forget your little a. So this time I have to transition based on the information given. I don't know a middle point. I'll have to use the intercept form with the p and the q. So one x-intercept is 0, so I'm going to call p 0. And the other x-intercept is 16, so I'll call q 16. So I don't know if you remember writing down the standard. What the standard says, you have to practice this skill from a written description, a table, a graph, and a word problem. So those are all of the variety of problems you see. Okay, so I'm going to go y equals a, x minus 0, x minus 16, and then we need another point. Too much going on here. So we need x comma y. Let's use 4, negative 24 and put that in the xy spot. And I'll wait a minute and let you guys find a. Maybe it's negative 1 again. It's not. It's a function, isn't it? Oh. Negative 12? Anybody get 1/2? Don't put your tongue in it. I'm questioning 1/2. I thought it was going to be negative. Because of the negative numbers, I'm thinking, wait a minute, it's supposed to be negative 1/2. I checked my signs. But then I consulted my visual, and actually this is a parabola opening up. Even though it's underwater, the arrows go up. It's a regular parabola with a positive a value. So you should assess the reasonableness of your answers. Say, does this match what I think it should match? All right, we got an a value of 1/2. Let's plug in a. We're going to start over. After you find a, you start over. This time we use p, q, and a. We don't use x, y. So 1/2 x minus 0, x minus 16. That's kind of weird. We don't have to FOIL it when there's a 0. But we do need to distribute. So I'm going to distribute this. Just the x instead of like a full FOIL. So that's x squared minus 16. And then one more time. Oh, that's 16x. X times x is x squared. X times 16, 16x. So 1/2 x squared minus 8x models this. It's got like a plus 0 at the end. Because the y-intercept is 0. So 0 at the end. The maximum depth, let's get that. We have to find the percent. Negative b over 2. 8 over 1. Sorry. Let's skip this. I don't want to spend any more time. I need to check your assignment and move on my life. And we're also not going to do letter B. So that's your final answer, 1/2 x squared minus 8x. Yeah. No, don't do B. Wait, what did you say? let's look through yesterday's assignment. I'll put the answers up here for you. 4, 5, 8, and 11. I believe I did 4 with you. Right? I did. Okay. Here's number 8. Wait. Here's number 5. Yeah, that's right. Mm-hmm. So minimum maximum is a y value. It's like what's the height? It's kind of like range, right? Like the maximum height and the minimum height. So I think that's kind of if you do that one. If you want to scan for increase and decrease.
No, yeah, I'm not really sure.
Do you know the vertex?
No.
You gotta find the vertex first, because if you know maximum, I was talking about how high do you go? Maximum height. Do you know the vertex? Okay, when I come back, I want to see yesterday 1, 3, 9, 10. I need to see the lots over. Good, and then 4, 5, 8, 11. 1, 3, 9, 10. Alright. 1, 2, 3, 4, 5. Good. Ready for further? Yes, lots of work in this section. Good, Cliff. Very good. 1, 2, 9, 10, 4, 5, 8, 11. What's going on here? Okay, I'll go to 8 now, so you can look through 8. And then ask a question if you don't understand. Like, we don't necessarily show it every step here. So if you don't know how it went from that step to that step, I can show some more details. Here's the even problem number 8. match. So the 3 and the 1 will be with it. So are we gonna do 132, 133 in the other day? Yeah, maybe we will do. No, you can just do the first at 31. So which one would you like? Yeah, easier than that. Okay. And then I'll show you number 11. And then you'll have a minute.